Okay. Good morning, everyone. My name is Allan Caine, and I'm here to talk to you this morning about medical imaging informatics and the need for a unified framework for medical imaging informatics. And how I'm going to talk about this is my abstract first, the introduction, then the radiological and imaging process. I'm going to talk about the goals of medical imaging. I'm going to talk about this conceptual and the unified framework, computational methods, the rationale for unification, and then give you my conclusion. First of all, to the abstract. First, we can think of a spatial database. You don't know what that is yet, but I will explain it. And a knowledge database. And together, you can think of these as essentially being a complete database of the human anatomy. Opposite that, we have the methods database. And you can think of that as being the state-of-the-art in medical image processing methods. What I want to know is what is the relationship between the methods database and this combination of databases that is the human anatomy. Indeed, the goal of the paper is to find a unified framework for medical imaging processing methods. Now to the introduction. Shortlift gives us 6 reasons why medical imaging is important. That is, why do we have a radiology department in a hospital? For diagnosis, for assessment and planning, for the guidance of procedures, for communication, for education and training, and for medical research. The modalities are the ways in which these medical images are made. Examples would be such things as X-ray, computerized tomography, ultrasound, magnetic resonance imaging, functional MRI, mammography, echocardiograms, images in time and motion, and images from microscopes. Why are there so many modalities in health informatics? Well, no single modality works in all cases. Research uncovers new modalities. There are new methods, i.e. the fusion of existing methods. We come up with new energy sources, i.e. magnetism versus ionizing radiation. We have new reconstruction methods, and there's a need for higher dimensionality, 4-dimension versus 3-dimension versus 2-dimension. What's the radiological process that we use in a hospital? Well, first there's an assessment of the clinical problem, and then that is followed by a request and a schedule for the exam. The exam is performed, and then that is analyzed and interpreted. The results are then communicated back for possibly another assessment of the clinical problem. This can iterate a few times, possibly until there's a final diagnosis of the patient's problem. Within this, there is the image manipulation process: processing, segmentation, feature detection, and classification. Processing means to enhance the whole of the image, i.e. contrast enhancement. Segmentation is recognizing objects, such as the region of interest. Feature detection is the extraction of useful parameters, such as the size of the heart or the size of the fetus. And classification is what kind of object is seen, i.e. a potential tumor. Now, let's take a look at a commercial product to see how this process is done. Let's look at Agfa's MUSICA. MUSICA stands for Multi-Scale Image Contrast Application, and it was presented by Dr. Neil Hunt of Agfa in November of 2003 at the IEEE workshop on image processing, actually right here in this room. This was a workshop that I myself attended. It's a commercial product that deals with contrast and edge enhancement and latitude and noise reduction. I will say, however, these are solved problems. It's difficult to assess this product because it is a proprietary method. We don't know what the formula is, but still it's worthwhile to go through as an example. Here is an example of MUSICA, and we can see that at the extreme left is the original X-ray, and then we can see at the extreme right the one that's been enhanced by MUSICA. And in particular, We can see, oh dear, this went too. We can see in particular where a particular bone structure comes out in greater contrast. This bright spot here is actually a prosthetic hip. Now, here is the original again. Here is MUSICA's version. And actually, what I tried to do just for some fun is to see whether I could get something out of Adobe Photoshop. And it's not bad, to see what it could do to get this bone structure out. Actually, it looks better on my screen than it did when it was reproduced on my PowerPoint slide. However, the real take-home message is here. When we blindly apply histogram equalization, which is really what's going on here, the result is disaster. We can see that the whole image goes to black. And the reason for this is because of the very, very bright area, and that's pushing the whole picture down into darkness. The conclusion is that one really needs to know what one is doing when applying these methods. Just applying them willy-nilly does not always work. And that's really the thesis of my presentation. So in this paradigm that Shortleff gives us, MUSICA lies within the first two items, processing and segmentation. However, it really doesn't do the feature detection. That still has to be done, as it were, by hand by a radiologist, and so does the classification. To me, the autonomous processing, that's the real challenge, to do these things autonomously. So what are the goals of medical imaging informatics? Well, Kulikowski sees the following goals. We want to develop a knowledge-based framework. We want computerized imaging that can capture the content of the semantics of the medical image. We want to use DICOM to communicate in a standard fashion. We want to index our feature content. We want to see the evolution of structured interpretation and image object description. We want to extend HL7 standard to embrace medical imaging informatics, and we want to provide for semantic search. So what is this conceptual framework that I'm talking about? Well, Brinkley and Ross have a very ambitious project where they see all medical imaging informatics along two axes. First as data and knowledge, and then as symbolic and spatial. So spatial data is simply the two-dimensional, three-dimensional, and four-dimensional images. It's the images themselves. The spatial knowledge is the relationship between the body parts. Symbolic data is kind of the boilerplate information that you would expect to see in a database, such as the person's first name, the person's last name, their address, their OHIP number, their date of birth. Symbolic knowledge is the unified medical language. That's the correct terminology that is to be used for, say, the parts of the body. Their conceptual framework here is that we have a spatial database and a symbolic database on a network. And then we have terminals for segmentation, feature extraction, classification, and for retrieval. So these all are mediating together to allow the person to retrieve information about any part of the anatomy of any kind of modality whatsoever. But I have a critique of this. It's very ambitious indeed, but the framework, in my view, is missing an essential piece to the puzzle, and that is that there exists no methods database. In other words, no how-to of the image analysis. In their framework, the image analysis is still done by hand. Every person is an individual, and there is no right or proper human anatomy, but there's a range of norms. Classifying all forms of illness detectable by a medical image informatics may be impossible or too difficult to achieve, and illnesses do not always manifest themselves in the same way exactly. To me, this is the improved framework. I've removed the first three terminals, and I've retained the retrieval, but I've put in the methods database, which you'll recall is what I think of as the state-of-the-art in image processing. The methods database, the spatial database, and the symbolic database, they all mediate together for the appropriate retrieval. So what are some of these computational methods? Well, Soutens and company, they took 57 pages to summarize the methods that they knew of, and the list may not have necessarily been exhaustive. And 57 pages is very long for a paper. There is no database of all of these methods, their merits, their disadvantages, and their areas of applicability. For example, Kildare and company sets out a method of detecting lesions in mammograms. However, the method only applies to mammography and only to the particular type of lesion under investigation. The method's suitability in other situations would need to be studied. So, typical classifications we have are computational methods such as spatial domain, frequency domain, Ballard-Hugh method. There's a Snake's method, which uses deformable curves, Ayachi's method, Hyper, Brooks' acronym, Bowles and Harrod's method, Fow and Hansen, Subterranean and Taylor, Van Horn, Day and company, Phillip and company uses a fuzzy logic, and the list goes on and on. What's important here is that each paper, and I've only given you a small part of them, is a 30-minute presentation in itself. So what's the rationale for unifying all of these various methods together? Well, we can look again at Brinkley and Ross and their anatomical hierarchy. And what I'm suggesting is let us associate an image processing method or methods with each of these nodes in this anatomical hierarchy. Again, what is the relationship? We have the spatial database, we have the knowledge database, and here we have the methods database. Again, what is this relationship? Let's think again about Agfa. There was a mitigating factor, and the mitigating factor was the prosthetic hip. MUSICA, it worked fine. Histogram specification, it's arguable, but I'm going to give it a check anyway. But what we did find out, that histogram equalization, that did not work. It went all completely to black because of the brightness of the prosthetic hip. So my conclusion is, if a computerized medical imaging system, like the one that Brinkley and Ross proposes and they're working out, if it purports to handle any medical image of any part of the human anatomy, then what computational method support needs to exist to make that medical imaging system possible? Thank you very much, and are there any questions or comments?
Start with you. I'll cede the questions. One of the questions I've got is, you mentioned during the presentation that there needs to be work done to HL7 to address medical imaging. What's the issue there?
Well, the issue there is that we don't want to have yet another system that works independently. We want to have a system that can communicate in the whole integrated system of a hospital. That's the issue. We don't want something that's basically a standalone database that can't interact with the rest of the systems that are used in a hospital.
What does that mean that HL7 needs to do then? Adopt DICOM, or what's the process there that needs to be done?
Well, I think that what needs to be done is that we need to be careful when we're putting together this grand database that in fact it's using that standard, so that we can have an information exchange that is indeed on that standardized basis, so that it can interact with other systems, so that we can, for example, have a patient record that is being kept in a way that is standardized throughout all of the systems in the hospital.
What kind of images can
The question was what kind of images can MUSICA work with? Is that what your question is basically? Yeah. Essentially, where I see MUSICA is that it is another method for, as I said, image enhancement. It lies in those first two. Now, the example that was given at the workshop was that of an X-ray, and I just simply scanned it out of there. Now, whether it actually handles mammography, for example, I'm not sure, because you mentioned that in your question. That would be something we'd have to talk to Neil Hunt about. And in fact, I tried to get a hold of him and was unsuccessful. I wanted to talk to him a little bit more about this product. So I'm not certain, I must be honest, but I do know that it will handle X-rays. Alex had a question.
Oh, I was just going to ask about your specific classification on the anatomy of the body. It seems that you're using that classification to classify the imaging methods. My question is that classification volatile or is it non-volatile? And if it is volatile, how will you deal with the change in classification?
So the question is the classification system volatile or non-volatile? Is it subject to change or is it not subject to change? The answer is that it would be subject to change. And the reason for that is that there's always research being done to find new methods. So how would you deal with that? Well, clearly you have to have an ongoing research being conducted to keep the database up to date. And that's how it would have to be done. So the answer is yes, it is.
How difficult will it be, in your estimation, to develop and implement this framework that you're proposing?
It's very ambitious. The question, sorry, I have to repeat the question. The question is, how difficult would it be to implement this? Brinkley and Ross are actually two researchers at the University of Washington. They are currently working on the spatial database and on the knowledge database. So it is a very ambitious project. In terms of trying to come up with the methods database, yes, it too would be a very, very ambitious project. This is something that I would suggest you could run by a funder for several years' worth of funding to try and put this together. So it's a very ambitious idea, but I think it's a worthwhile idea in terms of research to find out how you put this together. But remember, it's just not a simple idea of, well, here's the method, here's the body part, let's put them together. We've seen, even from the MUSICA example, that there are mitigating circumstances which influence which method that you're going to use. So there's a lot of research that needs to be done in order to come up with some kind of unified way in which to put and classify these methods so that they're useful to a medical imaging system.
With regard to the methods database, when you gave your initial presentation, I asked you about commercial product, the commercial products that have been used primarily by the mineralogy kind of industry, where they've got an array of technologies, if you want, to do enhancement or to select a feature or to sharpen an image. What are they missing that this technique would address? And have you looked at any of those specific products?
Mineralogy?
Yeah, the people who do like cut rocks in half and then look at the mineral specimens. That's where it's been used, a lot of that kind of work. It's used by geologists primarily.
So the question is, did I look at mineralogy?
Or did you look at any of the commercial products?
No, I didn't look at mineralogy. I was looking at products that were for health, in the health area. Okay.
So you're not familiar with the commercial offerings?
No.
My final point is you indicated that there would be a great deal of work involved in creating the necessary database. Have you given any thought to the technology that you might use in creating this? Like what mechanisms you would use? to create the methods database? How you might represent the methods in the database?
Well, I think that the question is, how would I represent this in a database? I think that's indeed part of the whole issue here is indeed how would you represent it? Because sure, we can come up with a database that is a complete long list, kind of a grocery list of methods, okay, in your database. But we need to know, for example, what are its advantages, what are its disadvantages, where can it be applied, where can it not be applied, and some experimentation is going to be needed to see whether the system is able to select the correct method based upon the database and the parameters that are there.
Have you given any thought, though, to how you might represent that information in a database?
Maybe you could be clearer on what you mean by represent then.
You have a method in a database. How are you going to indicate on the element that is that method? How are you going to indicate what that particular method is capable of doing? Or which kind of image to which it will be applied? Do you have any thoughts about that? You may not have. I mean, I'm just asking.
Well, some initial thoughts, as I said, like you're thinking about the fields in the database in terms of representation. Yeah.
Could be fields, could be other techniques.
Yeah. Well, again, there's going to be the method itself, the implementation of the method. That has to be there. The actual code that makes it work. Some things that I could think of is, again, what kinds of parts of the anatomy is it associated with? Again, where does it work? Where does it not work? What are some of the mitigating factors? What are some of the questions that would need to be asked to an operator, for example? For example, is there a prosthetic hip? Is there something that's metal that's caused a very, very bright spot? I'm thinking of the histogram equalization, where the person could be asked some questions. These sorts of things. But again, it's a question of it has to be researched and thought out, as to how these things are going to work.
Thank you very much.
Okay, thanks.